Alright, welcome back. You have any guesses at all as to what you're looking at right now? Do you have any guesses? Some of you might, and some of you might not. What you are looking at is, theoretically, I believe, the entirety of our observable universe. What you see here is the entire universe. And do you know why? Because we are in a very terrifying location right now. And I will go forward so that you can see where we are exactly. So you can see now, things are getting kind of crazy. Let's keep going forward a little further. I think we're almost back into the universe. I'm just focusing on our random star here, by the way. Looks like we are awful close to getting back into the universe. And everything is no longer redshifted. Okay, so any guesses as to what we were just in? It's probably kind of obvious, but those of you who aren't sure, we were in a black hole. This is black hole RS8496, which is just a random black hole in our universe. Nothing, there's nothing super amazing or super important about this guy. I don't think it's procedurally generated. I believe it is a legitimate black hole. And as you can see, the gravitational lensing around this black hole warps space behind it. What you are seeing, this effect, is actually normal space over here on both sides of it. Just what's behind it is being warped around it because, you know, light is also affected by gravity, and the gravitational pull of a black hole is so, you know, it's so insane that you that not even light can escape it. So, let's see. Yeah, and that's, I mean, as you can tell, you know, as you get closer and closer to the event horizon of a black hole, your field of view gets larger and larger around you. And again, I'm not a scientist or anything that can properly explain this, but, you know, I think it's a theoretical concept that the entire observable universe itself ends up coming into view from within a black hole. I could be wrong about that. I wonder what that is. Can't tell. It's too far away. Oh, it's a star. Okay. What's this? Is this a... What's this? Large Magellanic Cloud? It's not going to let us look at it, is it? Alright, anywho. So yeah, that's pretty neat. There's just a little foray into nightmare fuel. And, you know, it's not so much terrifying as it is just interesting. Apparently this black hole actually has planets around it, which we can see here. Because here is the black hole, I think. Oh, no, okay, this is the main sequence star. Oh, I may have been clicking on the, crap. I think I was, yeah. I was focused on this. I think I had clicked on the star by accident, so it took us to this star. So, one thing I did notice, when I went in here and filtered the objects. I removed all of the procedural stars, and when I removed all the procedural stars, it also removed a lot of the procedural planets, and that's why in the previous episode, there was a lot of things that we just couldn't see. So, you know, that's probably why things were a little strange there at the end. I am curious if we can actually find, like, I want to know how many planets. Oh, wow, there's a comet. There's a planet. Is it really? Towards Super Neptune. So these are planets orbiting around this star, I would assume, correct? And this star is procedurally generated, so it does not actually exist, unfortunately, but I do think it's pretty neat that, hang on. I do think it's pretty neat that the game does still show us, like, let's see, is this the closest one? Yeah. So here is the planet that is closest to this star. It has 2 moons, which are absolutely... Wait, I assume these are moons, aren't they? Yeah, they're dwarf moons. Okay, so they don't actually have information listed to them. And here's the second planet in the system. Ah, this is the one. Okay. I'm not sure why this one has such a I'm assuming it's this planet that has the tail. Yeah, maybe its atmosphere is burning. Oh god. Maybe its atmosphere is burning up. No, that's not what I wanted to look at. I want to look at this one. So it's got a tail behind it because its atmosphere is just being destroyed. I'm not 100% sure. It does have moons though, which is interesting. All of them are basically just molten rocks though, of course. Oh shoot, I didn't want to do that. Let's see. Here's the third moon, which is... Or not moon. Here's the third planet, which looks like it's a Super Neptune. Ooh. So this planet is... This is essentially what we think a lot of gas giants would look when they're this close to their parent star. Like if Neptune and Uranus and Saturn and Jupiter were closer to the sun, they could potentially look like this because, you know, just they're going to be taking in so much heat. And this planet doesn't actually have any main moons. It just has dwarf moons, or hot asteroids even. Let's see. What's the next one? Let's go to the next one. I don't know why I'm exploring these, but I want to. So here's the 4th planet in this system. Hot, arid Subterra. So yeah, this planet is... This is the 4th planet in orbit around this star, and it is as hot as Mercury, which is the closest planet to our own star. That's kind of crazy when you think about it. Look how massive and bright that sun is. That star, I should say. Looks like this this planet actually has a few moons, even. They're all very tiny, though. Oh, this one here is 82 miles across. This one here is 3,000 miles across. Oh, that's the planet. So the biggest moon on this one would be this guy right here, which is kind of what I was expecting. More just an asteroid than anything else. But still, pretty neat. Let's go to this. This is the one I'm interested in. This is a Temperate Neptune. I don't know why I'm exploring these fictional planets, but we can, just for the hell of it. Just to see what we can find. So here's planet number 5 in this system. And wow, look at all the moons it has. Holy crap. Temperate Neptune. Temperature of 119 degrees Fahrenheit. So actually not uninhabitable theoretically, but still so stupidly hot that we probably wouldn't want to ever consider trying to live there. It has a orbital period of 1.4 years. I'm assuming that's 1.4, not 1.4 thousand. I could be wrong though. Atmospheric pressure. Wow, look at that. This planet's atmosphere is ridiculous. I think we would probably be crushed under that. I could be wrong though, but I don't think that I am. 120 degrees. I'll bet this planet. Oh, it only has 1 moon, huh? This guy here. Let's look at him real quick, just for funsies. This is the only moon that's not a dwarf moon. 120 degrees here. Interesting. All right, let's check out the next one. That would be this fella here. This is a tiny little rock right here. This is ooh, cool arid Terra, -100 degrees. Yeah, definitely not something we could ever live on. Still cool, though. The greenhouse effect is only for, 3 degrees. It doesn't have an atmosphere, hardly. I don't believe. Probably doesn't have any sort of magnetosphere to go along with that. Wow, it actually has a... yeah, I was going to say, it shares a barycenter with one of its moons, because one of its moons is actually very large compared to the planet itself. That would be this one here, correct? Yeah. So, if what I'm looking at is... If I understand correctly what I'm looking at here, these two planets have a barycenter, which is... I think the barycenter is actually inside that planet, because it's not a very noticeable barycenter, but it's still there. We could probably, if I were to turn on the orbits here, it would show us the barycenter, I think. Yeah, the barycenter is in the planet, but that is it right there. And it's small, but it's there. Let's see. Turn this back off. No, crap. I keep doing that. Here's the planet that I'm kind of more interested in. This looks like it's a super Jupiter, so it's going to have its own ring system, and it's going to have a ridiculous number of moons, I would assume. Oh yeah. Negative 128 degrees Celsius. Look at this beautiful gas giant. I wonder what some of its moons look like. Oh wow, this one here must have atmospheric pressure of 115, temperature is 3 degrees, the greenhouse effect is 162 degrees. The mass, yeah, I think it's half the size of our moon. I want to look at this planet, or this moon. This moon here is interesting. I think this moon is a lot like Titan. Well, its atmosphere is ridiculous. It's got 115 atmospheric pressures, and it's flashing like crazy for some reason. I do feel like, hang on, real quick, let me... There we go. I don't know if that'll help anything at all, but... yeah, look at that. I think it's lagging a little bit now. Yeah, this planet is one that... This moon is actually one that wouldn't be too terrible to live on, assuming that the atmospheric pressure isn't so high that it just crushes you. I'm not even sure if that's how it really works. A solar day is 7.2 days, so that means it does have a rotation. It's not tidally locked, correct? From what I can tell. Yep, it is rotating. So this planet, or this moon's not always facing the sun. The same side, I don't believe, is always facing the sun. Although I could be wrong. If its axial tilt is like completely like 90 degrees off, then I guess the same side would. I'm kind of focusing on this right here to see if this ever actually goes into the darker side of the planet. And it doesn't look like it does. So maybe perhaps this planet is, or perhaps this moon is tidally locked in a strange way, like it is rotating, but its tilt is so off that it you know, it still is technically tidally locked in a way. I wonder what that little speck was. Oh, that little speck, I believe, is the... Oh, that's just an asteroid. Okay, never mind. Okay, I feel like turning the anti-aliasing up that high is screwing me now, because even my monster computer is having a hard time dealing with it. So let's turn it back down a little bit. Alright, well anyways, this has been weird, and I don't know really what I've been doing, but there's one more gas giant I do want to look at. This is probably another super Jupiter, right? Yeah, cold super Jupiter, cool super Jupiter. So this one is, the only difference between these two is the temperature. Let's go check this last one out. Looks like it's got a few moons as well. Oh yeah. I don't know what that is. Cluster. Oh, okay. It's a star cluster. Yeah, this super Jupiter's got some neat rings around it. I wonder what that is. I wonder what this is. Is there a moon that is passing through here? I'm guessing that there is, right? Something that's casting this shadow. Not sure what it is, though. But yeah, this super Jupiter is pretty cool looking. It is how many masses of Jupiter? It is 7.6 masses of Jupiter. So it's pretty dang big by most standards. All right. Let's see here. So here's the weird part here. If I go to filter objects and I do not filter procedural stars, does that remove the planets as well? It does not. So the planets stay. But if we get rid of theoretical planets, they're just placed in here by the game, these go away as well. Okay, so let's test my theory here. Let's go back to Earth. We know that's real. We know it's going to pop up. Okay, and now, by that logic, some of these stars that I'm looking at are real, correct? Because I turned off all procedurally generated stars. So, let's see, distance 8 light years, distance 312 light years. All right. Let's go to this. This is Sirius, Alibor, this is Canis Majoris, Gliese, I don't know, all these names. So this star is the real deal. This is a white main sequence star that does it have any planets, or is it a binary system? It might be a binary system with this guy. Yeah, Sirius B. So we have Sirius A, I'm guessing, and Sirius B. I may have already looked at these two. They are definitely in a binary like orbit with one another, which I can really show off. Is it R? Yeah, R goes up. Okay, there we go. So these two stars orbit one another, as you can see. After I crank up the time a little bit. There we go. So they're in an orbit with one another, which means it's practically all but impossible for there to be any planets around these. I'll turn on the orbits here and you'll see. And the very center is always going to be closer to Sirius A because Sirius A is larger than Sirius B. But they're real. They're in the game. They're here. So that answers my question. I would like to find actual planets that are in the game, though. I want to find a planet. That's a binary system. And I don't know how many of these stars are legitimate. I kind of want to avoid the blue ones. That's a binary system. That's a binary system. Okay, let's try this one out. So I think it's more common than not in space for there to be binary systems. It's actually more rare for a star to be by itself, from what I understand. So this star is not procedurally generated. This star actually exists. This is Telescopy HIP 90568. We'll go with that. And it does have planets, if the game created them. Okay, so the game didn't create them. These planets should be legitimate planets. I do have procedural planets turned off. So these planets do exist. These are real, legitimate planets. So that's cool. That's what I was hoping for. So, theoretically, and of course a lot of these planets are just ridiculously close. The furthest planet away does have moons, but the furthest planet away is very tiny, and its surface temperature is 314 degrees Celsius, or Fahrenheit, excuse me. And it's not here. Really? So it is procedurally generated. I could have sworn I turned that off. Well, if I do this, it'll pop up, I'm sure. Or maybe not. Will this one pop up? No. Will this one pop up? No. I don't get it. Procedural on real stars. Ah, okay. Procedural planets on real stars. Okay, so it's still going to show me. That's what these are. It's still showing me the procedurally generated planets on this real star. Which is not what I wanted, unfortunately. It's kind of like we're just playing a game of, you know, theoretical, you know, astronomy, where we're like, oh yeah, you know, here's a star. There could theoretically be 10 planets around it, and they could all be from this far apart from the star, and they could all have this temperature, you know, and stuff like that, which isn't really what I wanted. Let's go back to Earth again. That's kind of disappointing. I don't really want to have fake planets. I want, which I know it's asking a lot, because I mean, look around you. Even if all of these stars are legitimate, to have taken the time for us to have mapped out what planets are orbiting them, to figure that out, there's not enough time in the history of the universe for us to do that. But you can't blame me for wanting to see it. Let's try searching. No, not that. Where's the star search at? Here we go. This one. So let's search for 100 light years. And let's filter the settings. Let's see. Sun count. We only want one sun with any number of planets. I don't know what planemo is. Let's hang on a minute. I'm curious. What does planemo mean? Does anybody know what planemo is? Celestial object of planetary mass, one that is larger than an irregularly shaped asteroid, yet smaller than a nuclear reactive star. Like a black dwarf, kind of? Now, we can leave planemos on. They sound interesting. Okay, object to system's main star. I don't care about that. Object's parent sun, I don't matter. That doesn't matter either. Object to search planet only, moon only, planet and moon. All stars, procedural stars, real stars only. There we go. And the object parameters, let's leave all that off, because I don't think I really care. And there's a lot more popping up than I would have expected. But we did also search by like 100 light years away. It's a heck of a search. Let's see. So, see, if we filter by life, theoretically there are 3 planets around this star that have life. But I am willing to bet that they are all procedurally generated. Let's go to it and see. We'll go to this star. Up. Okay, yeah. The planet is not here. I'm sure the star is somewhere. Or is the star also fake? Hello? Yeah, I think the star in this system that it took us to is also not real, unfortunately. Oh, wait, there it is. Okay, excuse me. Yeah, that's the star, and the planets themselves are procedurally generated, so they do not exist. But it did throw a few planets our way, like the 3rd planet in this system, with a surface temperature of 104 degrees. It's a temperate lacustrine terror with life. A cold super Neptune, which apparently they think might have... Oh, the planets, I'm assuming. Or the moons, which... Yeah, this one here. Cold, airless, mini Aquaria with life. Possible. Negative 285 degrees Celsius, though, kind of leads me to doubt that. And this 8th planet here also has a moon that might have life on it, it looks like. But I don't believe any of them are going to show up, because I do have... Yeah, I do have procedurally generated planets turned off. So, man, that's a bummer. I wonder if we actually know that these planets exist or not, you know? I really don't know for sure. So this is just a moon. This is a moon around that planet right there. Frigid mini Jupiter. That is the main star, and then you have 8.1, 2, 3, 4, you know, all these planets that are the sub. Now, this planet here is actually, the planet itself is supposedly habitable based on what this game's logic has dictated by placing it around this sun. And like I said, I don't know, or this star, I don't know if this planet actually exists. I doubt that it does. And I would seriously doubt that it looks just like this. But it is interesting that it has the parameters to be a legitimate, you know, planet that we could potentially live on. And the surface temperature is ridiculously hot on all of these, unfortunately. So even though if we could survive, maybe it would be god-awful. And I wonder if this hurricane is actually... No, the hurricane is locked in place. Okay, just the planet. The planet itself will rotate. So it looks like, even with the filtered settings that I have on right now, having real stars on doesn't matter. I don't know how to actually turn some of these other parameters on right here. It looks like they're all locked under another setting. But anywho, I do find it interesting anyways that we found that many stars. I mean, we could even, we could take it a step further and, take it down to 10 light years, which is ridiculously close to us. And, we only want to find real stars, and we only want one sun, so no binary systems. And I think there are so within 10 light years of, oh, wait a minute, is this from where we are right now, or is this from, hang on. I do not want to do this from this system. I want to do it from Earth and see if we get any different results, because, I don't want to kind of bug that. Also, it seems that we are facing the wrong way there. I think that's right, isn't it? Or is it not? Kinda. Kinda, sorta. Let's see. We'll go down. And this is more visually appealing because this is what we... See, this is what we perceive our planet to look like based on what we've, mapped out thus far. Call me crazy, but I think in space, actually, it's different. But it would just fuck with our minds. So we actually depict the Earth as looking like this, when in reality, I swear, I think it looks like this. I think. I don't think I'm wrong, but I could totally be wrong. But anywho, let's see. That's good enough. This actually gives you a good idea of just how just how off our axis is, as far as our like, see right here, our axial tilt is 23 degrees. Even though the poles, like, even though the planet is, straight up and down like this, we are tilted 23 degrees. Like, from here to here is 23 degrees, and that's, I think that's a big reason why we have seasons the way that we do, but I could also be wrong there. I'm not 100% sure. But either way, pretty neat. Let's try doing that search again now from here. Yeah, that did turn some other stuff up. Hey, Bernard Star, I've heard of that one. Lumen. So this is our sun right here. I think that's our sun, if I'm not mistaken. Yes. Ah, yes. Our sun. Hello, sun. I don't think we could ever see... Nope, there's somebody. Who's that? Is that us? Yep, that's Earth. We could still look around real quick, see if we find any of our other planetary buddies, but I wouldn't count on it. Oh, wait. Nope. Yeah, we did. Here we go. I bet that's Mars. Yep. I bet that is Mercury. Yep. And that has to be Venus. That's Jupiter. Wow. That just puts it in perspective how large Jupiter is, how much further away Jupiter is, and it's almost just as bright as Mercury, which is the closest star to our planet, to our sun. Oh, this is probably Venus. Yep. And this is probably Saturn. Oh, no, that's Procyon. Sure, why not? Anywho. So there are, within 10 light years, based on our filtered settings, if we go for real stars only, there are 5 stars within 10 light years of where we are, that's relatively close, not gonna lie. Now, I don't know if these are red giants, or red dwarfs, excuse me, or, what kind of star they are. It looks like they're all a different type of star, because our star is class, in a different class than them. I don't really know what that means. But let's go to the closest one, Proxima. I think we've already been to Proxima, I think. Or maybe we haven't. Let's check it out. Okay, here we go. Proxima Centauri is a red dwarf with 2 planets that we know of orbiting it. I wonder... Yeah, Proxima C, Proxima B. hot superoceanic super Aquaria, and a frigid Neptune. They must be pretty far apart from each other. But these should be real planets. We should be able to see these, right? Yeah, finally. Finally some actual planets that are legitimate, that exist for real. Cool. Of course, it's a frigid Neptune, so there is no real surface for us to ever colonize or anything like that, but it's still interesting. Now, this is probably the more interesting one of all of them, out of the two of them, because the temperature here, whilst negative 300, I should say, is, you know, it's easier to stay alive in the cold than it is to stay alive in the heat. You know, like, we can send a rover to Mars and it be negative, 100 degrees, but we can't send one to Venus and expect it to survive for more than a couple of hours, maybe, because it's so hot. So, that's just part of it. All right, that was cool. I'm glad we found at least one planetary system. Let's check out Bernard Star real quick. Oh, I gotta take this off, I think. Here we go. Okay, so Bernard Star. I wonder if Bernard Star has real planets or if these are also generated. What? I'm a little confused. Is this thing really that far away from its parent star? Hang on, let's go back. Whoa. What is with this sun? Bernard's star is... Why is it shaped so elliptically? What's wrong with this thing? It's like an egg. Hang on, I'm curious now. Yeah, it's... So, yeah, that is the star that we were looking at. Or that's the planet. And there's the next one, and the next one, and the next one, and the next one. So the closest planet to it, a solar day, is only 9 hours, so it spins pretty dang quick. Its rotational period, yeah, axial tilt, 86 degrees, good lord. I'm curious, where is the... It's 2.4 astronomical units away, so it's pretty far away from this star, but it's still ridiculously hot, which is crazy. It has 48 moons. Good lord. I wonder, where is the, It's 1.4 masses of Jupiter. I'm curious as to what the apparent size... Orbital period, here we go. It takes it 1.6 years to go around its host star. And this is a real planet that we've discovered then. Wow. Look at that. Let's turn this off. A hot Jupiter. Very hot. Surface temperature of 913 degrees Fahrenheit. Atmospheric pressure, though. Oh, wait, no, it's 1.10 to the 6. Okay, yeah, we would die. We would die anyways, obviously. There's no doubt about that. It does have two main... It has one small, little, tiny moon and another moon that's actually really big in comparison. There we go. And, again, this is not procedurally generated. This is... a legitimate, this is a legitimate star with legitimate planets and moons around it. That's neat. Okay. Man, look, the difference in temperature between these two is hardly noticeable at all, despite the difference in their orbits. And this one even has a few moons, although they don't seem to be... Oh, it has a barycenter with one of its moons, and it has to be this one, I would assume. Oh, I'm sorry. It has to be this one, I would assume. Oh, yeah. Yeah, these two guys here are way too close to the same size to not have a barycenter. This one's mass is 1.8 masses of the moon. This one is 0.6 masses of Earth, I think. I'm not 100% sure. Let's see, let's go back. I am curious about this star more than I am the other ones. Let's go to, or this planet. My terminology is just whack. Here we go. Warm super oceanic Aquaria. I'm curious about its moons. It has 2 moons. Yeah, this is what I was hoping for. This one here. Look at this moon. Temperate arid subferia. It does not have. I don't think it has any. It has a rotation. Its apparent magnitude. Atmospheric composition. I was looking for. Here we go. 3.34 times 10 to the 5 atmospheres. That's kind of nuts, from what I can tell. But this planet, or this moon, not very large, but, I mean, look at the surface temperature, 60 degrees Fahrenheit. I mean, that's something I would live on if, you know, there was oxygen to breathe. And there's one more I wanted to look at. I wanted to look at this guy here, just to see if this cool super Jupiter has any moons around it that would potentially have a warmer temperature than it does, but it doesn't look like it. I probably wouldn't have expected as much. If anything, I think this would be the winner right here if we had to choose one. Let me see where it's been pelted by, just like our own moon. It's just been pelted over the years by random meteorites and asteroids and stuff. All right, that's cool. That is very cool. So we still have Ross 154, Lalande 21185, and as our own solar system. I don't know if we went to Wolf 359. I may have skipped Wolf 359. We'll go back to it and look at it in a second, in the next episode anyways. So, yeah, thanks for watching.